So in today's lecture, we'll talk about primarily we'll talk about the group one elements, but we'll just have an overview of the periodic table again for Mahab. So yesterday we talked about what is the periodic table. So the periodic table is a regular arrangement of elements according to their increasing atomic number, right? And the periodic table contains vertical columns and horizontal rows, right? So the vertical columns are known as groups, and the horizontal rows in the periodic table are known as the periods. There are a total of 8 groups in the periodic table and 7 periods. The group numbers represent the number of valence electrons that an element possesses. So, for example, if an element belongs to the group 3, it will have 3 electrons in its outermost shell. Uh, Whereas, on the other hand, if an element has a group number of 1, so it will have only 1 valence electron. And the group number also helps you predict the oxidation state of that element. Because, for example, if an element belongs to group 1, so it has only 1 electron in its outermost shell, right? So it has a tendency to share 1 electron, and when it loses that 1 electron to another element in the form of an ionic bond, so that element gains a charge of +1. So the group number also tells you about the oxidation state of that element. So that is the main significance of the groups. We also talked about the periods. So the periods here, they are the horizontal rows, and there are 7 periods in total. So the first period contains only 2 elements. We have the hydrogen and hydrogen and helium in the first period. Okay. So hydrogen है हमारे पास first period में, and we have helium in the first period, right? The second period जो है, so the period number basically tells you the number of shells which are occupied by the electrons in that element. So for example, if an element belongs to the first period, let's say we take hydrogen and helium. So as I hope you have the periodic table open up with you, so so that it's easier for you to understand what I'm talking about. So hydrogen and helium, they both belong to the first period, right? That means that the electrons of hydrogen only occupy 1 shell, right? So hydrogen has 1 electron, so it will only occupy the first shell. Helium, on the other hand, also belongs to the first period, so it has 2 electrons, and they both orbit a single shell. Let's take an element from the second period. So, for example, we have lithium from the second period, right? Now, lithium has 3 electrons. So, since it belongs to the second period, that tells us that that the electrons of lithium will occupy 2 shells. So, it has 3 electrons that occupies 3 shells, right? That's what period numbers tell you. And period it is important in also predicting the physical and chemical properties of that element. Because as the period number increases, for metals, as the period number increases, the reactivity of the metals increases. For non-metals, it's the opposite, the other way around. So, for example, if you have non-metals, so if you move down the group, or if the period number increases, the reactivity of the non-metals decreases, right? We'll talk about this in much more detail in the upcoming lectures, right? So each period contains elements with chemical and physical characteristics that change progressively from metal to non-metal, right? Okay, so these are some of the important groups of the periodic table. So we talked about this earlier as well yesterday. We have group 1, group 2, group 3, they're all metals. The most high yield groups that you need to know for your Cambridge exams are group 1 and group 2. They're very high yield, and you're tested on these groups frequently. So group 1 is known as the alkali metals, and it consists of these metals. The group 2 consists of the earth metals, also known as the earth alkali metals. The group 7 is consisting of the halogens. So there's fluorine, bromine, iodine, and acetylene. And the group 8 consists of the noble gases, and they're all inert. They don't react because they have stable electronic configurations. And the block of elements in between the groups 2 and group 3 is known as a transition element, right? And they're all metals. We'll talk about metals in much more details, right? Okay. So, so the uh, in the periodic table, the there is like a separate there are like two blocks of elements, right? So you have a periodic table, the large portion of the periodic table, which you see on the top, and then you have a very small. So you have like this. I draw the periodic table. So you have like a periodic table. This is like the periodic table, the shape of the periodic table. This is like the upper block of elements, and then you have another small block of elements at the very bottom, right? And these are very rare elements. So the first row is known as the actinoids, and the second row is known as the lanthanoids. And they're not really important at your stage. So this is how the elements are represented in the periodic table. So the elements are basically they are represented by their chemical symbols. So for oxygen, here as an example, the chemical symbol of oxygen is O, right? The chemical symbol of oxygen is O, so that's oxygen. The smaller of the two numbers, so we also do see two numbers. The smaller of the two numbers is the proton number. Proton number is also called as the atomic number, also known as atomic number. And this tells you the number of protons or the number of electrons that this element is not charged. The larger of the two numbers is the atomic mass. Atomic mass is also called as the molar mass or the relative atomic mass. It's also known as the nucleon number. You get same thing. So this is just electron configuration. I think we have done it already. So if we just go over electronic configuration briefly. So in the middle, we have the nucleus, which is made of protons and neutrons, and we have the shells, which contain the electrons, right? So the first shell, the rule is that the first shell occupies only two electrons. It has space for only two electrons. And the successive shells contain eight electrons. So every shell after the first shell that you draw will contain eight electrons. That is the octet rule. See, the first shell has a maximum of 2 electrons, the second shell has a maximum of 8 electrons. And we can use the periodic table to write the electronic configuration of the elements as well, right? So this is not really important. Uh, hmm. So we'll begin with the elements of the first group.